So in the previous part of the video, you remember that we have discussed in detail regarding the difference between these three techniques, right? Ensemble techniques, bagging, boosting, and stacking. The important thing before I will jump towards the algorithm side, in the very first part, we will start with ADA boost. I just want to give you a motivation why actually this algorithm studying is required. What is the motivation actually behind this boosting algorithms? And is that genuinely useful, or can we skip this portion altogether because already we have covered up so many algorithms in our previous modules? So let me give you a few answers here, and then maybe we can start in the upcoming videos the discussion behind the you can say ADA boost algorithm. The very first thing which I hope that you have learned from this introductory module of boosting is that this specific algorithm simply works by combining weak learners, right? That's why we are saying that it's a sequential learning algorithm. So it's just that if, let's say, we have multiple models working together, again, we are not here relying on a single model result. And that is the main reason why it is called ensemble. What we are doing is we are trying to see that wherever the model is going wrong, we are using other model to train that wrong things. So we are somehow rectifying our models and trying to curate at the end model which is a strong learner, right? That is the whole approach towards this boosting algorithm that we have discussed till so far, right? Now, what is the motivation behind that? Because with this approach, it actually improvises the robustness of the model as well as the accuracy of the model. That's why you will observe that in almost all the domains in machine learning, whether you're talking about banking domain or you're talking about healthcare domain, fintech domain, almost everywhere in machine learning, these boosting algorithms are being used internally. You will see that in the companies, there is already a pipeline which is set, and people usually definitely try to go for either random forest or XGBoost, both of them, because they will provide a competitive results altogether as comparable to the simple techniques that we have explored in the starting of the course, right? Now, the next important part which you will observe in this particular algorithm is the concept of bias variance trade-off, as we have discussed, right? So what is happening is somehow with the help of this algorithm, my model will be able to reduce the biasness. My model will be able to reduce the problem of underfitting, where if my model is not able to understand the simpler features in the very first go, it's okay. We will be having multiple variations of the models, and at every point of time, whatever things my first model is not understanding, my second model will be able to understand. My second model is not understanding, my third model will be able to understand. So what is happening is we are trying to reduce the bias and variance, getting the ideal situation altogether. So variance is also in a control, and biasness is also we are able to improvise. Last thing, all this process that we have explored till so far in the boosting technique will definitely improves the generalization of the model. And if you remember from the very starting of the course, I am talking about this term a lot, that at the end of the day, what we want is we want a model which is a good generalized model, right? Which is basically able to give us a better result on the unseen data, test data that we have, right? So that will only be feasible if we will be having a generalized model altogether, right? Then only we will be able to get an efficient result. Then only we will be able to get a good accuracy, I would say. And that is the core idea, that why we are discussing the boosting algorithms in a lot more detail in the upcoming section of the videos. So I hope that now you have a great motivation to start. So I will see you all in the upcoming video, where now we will directly jump towards the internal intuition behind the ADA boost algorithm.